Hello, my name is Terrence Tam. I am the president and a director at Snowcode Makerspace in Everett, Washington. Behind me is a laser that some of my members and I have been building for the last 6 months. It is going to be released under an open source license. It is a 3D printable laser that is optimized for makerspace operations. And let me tell you exactly what I mean by that. Okay, let's start with a traditional laser cutter. So this is a traditional CO2 laser cutter. You can see the tube is laid out on the back here, and the tube fires into the first mirror, then bounces off into the second mirror, then over to the third mirror before firing down into whatever you're cutting on the honeycomb bed. Now, it is we should note that the tube is mounted to the back of the machine, and so this distance here, which I'm going to call 1, and this distance here, which I'm going to call 2, basically will vary depending on where the cutting head is positioned across the bed. And that means that it's going to be very hard for us to seal off these lenses. Now, laser optics die when smoke basically gets onto the lens and you fire a laser into it. It basically bakes the particulate mixture, the particulate stuff from the smoke onto the lens surface. So you can imagine that these lasers require quite a bit of cleaning to keep them running. And anytime you really touch these optics mounts, because this is also how you're aligning the laser, you really have to go through a realignment procedure, especially if you took the lenses out and put them back in for cleaning. You can try to clean them in place, but basically when you're stressing on the lens, there is a chance that you're removing the lens as well. So anytime you clean the lens, your best practice is to do a little bit of cleanup and realignment, or at least alignment check on the laser optics afterwards. So not exactly ideal. So this is the laser that we are building. And I will have you note the first change that we've made is we've mounted the laser tube onto the gantry itself. So what that allows me to do is it allows me to basically couple this laser tube to my mirror box with a silicone part that allows me to position the laser tube, move it around a little bit, but basically keep any of the dust and debris out of the laser box. Now there is still a variable beam path area right here between where the beam exits the mirror box and before it enters the third mirror that turns the laser 90 degrees downwards to fire into the material substrate. But we can solve that by putting a zinc selenide window. Zinc selenide is transparent in both the infrared wavelength and the 650 nanometer red wavelength that is used for aiming the laser. So we can put a zinc selenide window in each of these optical openings. And the nice thing about an optical window is there's no alignment requirement on it. You can take it off and clean it and put it back in, and that does not affect the alignment of your optics. And so that right there is already a huge win. We are going to further make this a little more maintenance friendly by putting a air knife in front of the zinc selenide windows. So we are going to be running a compressed air line all the way up to the first window here and all the way to the gantry, onto the X slider, and onto this optical block here. And essentially the compressed air is going to form a laminar airflow over the lens, and that should prevent the smoke ever from touching the lens. So we should be seeing a much better lifespan on our optics. The mirrors themselves will never get fouled because they are completely sealed inside the mirror box. The zinc selenide windows will be protected by an air knife and should also last quite a bit longer. And because the mirrors don't get fouled, we can use much higher transmission, much higher reflectance mirrors. We can actually use an unprotected gold mirror, which normally you wouldn't use in a laser cutter you would use something that is about 90-ish% efficient in terms of reflection, but we can actually use a 99% unprotected gold mirror because that mirror should never foul up because smoke would never get to it. So anyway, the project's been going a lot longer than I'd like. That's partially my fault due to my travel schedule, partially just the nature of building it with a community of people, and we are having a fun time building it. I want everyone to learn about lasers as much as they can. So I'm perfectly happy to teach, but it has slowed us down in terms of progression a little bit. This layout isn't without drawbacks. Because the laser optics tube moves back and forth, there is a lot more attention have to be paid to the wiring. And you can actually see in here, I've spent quite a few iterations spinning through different ways of laying out the drag chain and the drag chain cable, so that we can run high voltage cooling water, compressed air, and a bunch of other stuff onto the gantry. But I think it's going to be worth it anyway. Yeah, so this is my entry for the 2025 Open Source Conference in San Francisco. If you guys like it, please accept the project. I am hoping to also build a smaller one that I can bring to Open Source for the actual demo. Planning on driving down and bringing a smaller copy of the laser, hopefully working by the time Open Source happens. So, peace. See you around.